The weldability of aluminium and its alloys is influenced by their composition and the welding technologies used. Pure aluminium and aluminium manganese alloys are very suitable for welding. Increasing amounts of magnesium in aluminium-magnesium alloys increase the oxidation tendency, making such alloys more difficult to weld. The magnesium burn-off is compensated for by using filler metals with higher magnesium contents. Compared to the non-heat treatable alloys, the heat-treatable alloys have a lower weldability. It is also not possible to use filler metals of the same composition as the base material. Consequently, non-heat treatable filler metals are used for welding heat-treatable alloys. Three solidification mechanisms affect weld cracking sensitivity: pure metal cooling, eutectic at grain boundaries, and critical temperature intervals. Choosing the right filler metal is essential to ensure adequate amounts of eutectic, which can reduce crack risk during welding. Aluminium-silicon fillers generally present a lower cracking risk compared to aluminium-magnesium-manganese fillers, though this trade-off may reduce joint strength. The Holdcroft test is a well-known method for determining weld cracking sensitivity in aluminium alloys, evaluating both with and without filler metals. 9 aluminium alloys were tested and compared using the fishbone specimen. The factor A, in percent, is a measure for the hot cracking sensitivity. As can be seen in the figure, the aluminium-magnesium types of alloys have a low hot cracking sensitivity, A about 15%, and the aluminium-copper-zinc-magnesium alloys build the other extreme with high cracking sensitivities of A about 80% and higher. The silicon and magnesium contents have a very pronounced effect on the weld cracking sensitivity. The heat-treatable alloys in particular have compositions which lie in the critical region. Consequently, these alloys are welded using non-heat treatable filler metal alloys, even though this tends to reduce the strength at the joint. The use of heat-treatable filler metal alloys has proved to be unsatisfactory. Increasing solidification range heightens cracking susceptibility, with pure aluminium showing minimal sensitivity. Aluminium alloys with copper demonstrate pronounced solidification intervals, leading to significant cracking risks. Filler materials used can be divided into 3 groups containing silicon, copper, or magnesium as the main alloying elements. Depending on the alloy, varying amounts of additives can be added, for example, manganese, chromium, titanium, as well as iron. Zirconium additions to the alloy. 2319 improve the heat treatability and deliver a fine-grained structure. The weldability of aluminium encompasses its material properties, design reliability, and manufacturing considerations, emphasizing metallurgical aspects. Thank you for watching. If you found this information useful, please like, comment, and subscribe for more insights on metal welding.